Well, it's Friday afternoon, about 4:30, and here I am sitting still in school while you guys are all going to the football game to get wet. Um, I'm going to go ahead and record this pre-lab so that you can work on it over the weekend if you have the opportunity. This is what I have on the charts for next Wednesday, Thursday labs. Hello? No, we haven't found the brownies yet. Talk to you later. Okay. So I'm going to do this in 2 sessions. The first session will be background information. The second session will be writing out the lab. Okay, the lab will also be loaded onto Moodle, so you can read through the lab. You can even print it out if you want to, and get the background from that if you don't want to watch the background. The beginning question is, can patterns be observed in the solubility of certain cations and anions? We're going to be testing cations and anions. We're going to be looking for precipitates. Now, the background talks about salts dissolving, dissociation and dissolving. When a salt dissolves in water to form an aqueous solution, it exists in solution as individual ions. We've talked about this. We talked about the fact that, does the pen want to work today? Yeah, here we go. Sodium chloride, when you put it into water, the sodium will break off from the chlorine. And it does that because those water molecules surround the sodium, the negative end of the water molecule, and the positive end of the water molecules will surround the chlorine so that they get pulled away from that whole crystal lattice. Okay, a good example of this is this picture right here. Here you can see, maybe, the crystal lattice of salt. And the water molecules, there's the red is the oxygen and the blue is the hydrogen. And you can see the blue ends, the hydrogen, which is more positive, are surrounding the chlorine. And you can see that the oxygen end surrounds the sodium. Okay, so that is what happens with an ionic substance that dissolves in water. This is a polar substance dissolving in water. This is sugar molecules, and the water comes and surrounds the sugar molecules. Okay, this is true dissolving, whereas the other picture is really what we call dissociation. Okay, and you'll get copies of these on Tuesday before we do the lab, this set of notes. A reminder, the oxygen does not share equally, and I like this picture because the hydrogen atoms do not have, you can see that it's not equal sharing. The hydrogen doesn't have it as much as the oxygen does. They're much closer to the oxygen nucleus because of that electronegativity. So that gives that oxygen nucleus a negative charge and the hydrogen side the positive charge. Actually, not oxygen nucleus, oxygen atom. Sorry. All right, back to the lab, the background information. So in this first part, it talks about sodium phosphate dissolving. And you can see sodium phosphate dissolved in water. You have sodium ions, you have phosphate ions. Silver nitrate dissolved in water. You have silver ions and nitrate ions. We talked about polyatomic ions on Monday, or we will talk about them on Monday. And they just act like groups of junior high girls. They stay together. They are covalently bonded with a charge. Now, if we mix the 2 solutions, you'll notice at the bottom of this flask, the silver and the phosphate have clumped together and settled to the bottom. They have formed a precipitate. The sodium ions are still swimming around there. The nitrate ions are still swimming around in there. Okay. The net ionic equation means we're going to use only what reacted in the equation, not what got left behind. So if we look at our solute, our precipitate, silver phosphate is what we ended up reacting with. So find the silver and find the phosphate, and your net ionic equation is just the silver and the phosphate making silver phosphate. Everything else, the sodium's the same on both sides, and the nitrates are the same on both sides. They are what we call spectator ions. They're just sitting back and watching. All right, that's called dissociation. So now we are ready to do the procedure. So I'm going to go ahead and stop so that this doesn't get too long, and then we will, the second video, we'll take that up. All right.